Hello and welcome to 1-6. Today we're going to be looking at patterns and sequences. And our goal is that you will be able to find patterns and recognize, describe, and extend patterns in sequences. Now I liked this picture because I thought it was a quick little picture that describes what we're going to do today, talking about the position and the value of terms. So let's get started. All right, so here I just wanted to show you a quick picture that kind of shows how each month, so month 1, month 2, month 3, month 4, Eva is getting some DVDs. She gets 3 new DVDs from her DVD club each month. So we can see that the value of the term would be 3, 6, 9, 12, and its position would be 1, 2, 3, 4. Talking about the months. So the number of DVDs Eva has after each month shows a pattern. We're adding 3. You can see add 3, add 3, add 3 is our pattern. Now this pattern can be written as a sequence, 3, 6, 9, 12, 15, and so on. A sequence, here's our vocabulary words for this chapter, or this lesson. A sequence is an ordered set of numbers. Each number in the sequence is called a term. So each one of these is a term. So we can refer to them as terms and not necessarily numbers. In this sequence, the first term is 3, the second term is 6, and the third term is 9. So we can remember that each of these are called terms. When the terms of a sequence change by the same amount each time, the sequence is an arithmetic sequence. So because I have plus 3, plus 3, plus 3, plus 3, that is my sequence. Then I can say I have an arithmetic sequence. Now sometimes it might be plus 3 minus 2, plus 3 minus 2, plus 3 minus 2. That would be an example of a non-arithmetic sequence. Okay, let's try some problems here. So we need to identify a pattern in each arithmetic sequence, and then we need to find the missing terms. So I have the number 3, 15, 27, 39. So the first thing I'm always going to try is seeing, am I adding the same number each time? So I'm going to look. 3 plus 12, and then to go from, from 15 to 27, I would add 12. And then to go from 27 to 39, I would add 12. Okay, well, I would say we have found our pattern. Our pattern is to add 12 each time. So I'm going to say, what is 39 plus 12? 39 plus 12 is 51. And 51 plus 12 would be 63. Okay, so now this time we got lucky because it was adding. But that's always what I check. Am I adding the same number each time? Or is there a way I'm adding and subtracting, or subtracting, adding? Because that's going to be our easiest one to figure out. Now when we start adding in, multiplying, and dividing, now things get a little bit trickier. Okay, but first let's go down here to the next one. So I see 12, 21, 30, 39. And now I didn't write this on here, but the directions for this problem say use a table to find a pattern. So I wanted to show you how to use that table. So the position is going to go on the top. This is the first number in our sequence. Here's the second. Let me rephrase that. This is the first term. This is the second term, third term, fourth term. Okay, it's its position in our sequence. Now the value of each term would be 12, 21, 30, 39, and then we have to find the fifth and sixth position. What is the value of those terms? Okay, so let's see. To go from 12 to 21, I'm always going to start with adding, so I'm going to add 9 to go from 21, oh, add 9 again. Ooh, it's looking good, but I always need to check that third one to make sure that it's the same thing, because they might throw a loop into it or a wrench into what you think is going to work, so we better check. 30, yeah, plus 9 again. So I just have to say plus 9 would give me 48, and 48 plus 9 would give me 57. Would be my next two terms. So it says identify a pattern. So if I was going to write this out, my pattern here is plus 12. And then find the missing terms. So my terms are going to be 51 and 60. Ooh, I didn't leave myself enough room to write the answer there. Let me scooch that over. Oh, it's going to scooch everything over. Okay. 51 and 63. So that's how I would write my answer. The pattern is plus 12, and then the terms are 51 and 63. Now for here, my pattern is plus 9, and my terms, my missing terms, are 48 and 57. Then I will put a box around my answer so that Mrs. Hammer can easily find it on my paper. And let's go to some more examples. Okay, so again, I wanted to show this to you. Here's an example of an arithmetic sequence where we're adding 2, adding 2, adding 2, adding 15, adding 15, adding 15. Now sometimes it's not going to be an arithmetic sequence. And we're going to add 2. Plus 3, plus 4, or multiply by 3, multiply by 3, multiply by 3. Now, when I looked at this, originally I thought, well, I'm multiplying by 3 each time. That would be an arithmetic sequence, right? Now, arithmetic sequences are just adding and subtracting. When we get to non-arithmetic sequences, it's also going to involve multiplying and dividing, and it could also be adding and subtracting. It's just not going to be the same over and over again. So let's try out a non-arithmetic sequence to give it a shot. Identify a pattern in each sequence. Name the missing terms. Okay, so I know already I can't just add every time on this time, unfortunately, because I know this is going to be a non-arithmetic sequence. So I'm first going to look at between 4 and 15. Now I can't multiply by anything to get to from 4 to 15, because 4 would go 4, 8, 12, 16, doesn't hit 15. So I know I'm not going to start by multiplying. So let's just look at adding. 4 to 15, I would be adding 11. So now I'm going to look at from 15 to 8, what happens. Well, I can't divide. 15 divided by 2, I can't. It's not 8, so I know I'm not going to do that. Let's try subtracting. Now to get from 15 to 8, I would subtract 7. Okay, and now let's see if I'm adding 11 to go from 8 to 19. Ooh, I am. And then to go from 19 to 12, am I subtracting 7? Yes, I am. And then adding 11 and subtracting 7. Wow, now that wasn't too bad. It was just an adding subtracting problem. So a reason why it's non-arithmetic is because it's using both adding and subtracting. We're not doing the same by adding each time. So my pattern is add 11, subtract 7. My missing terms, now that's what I need to figure out. 16 plus 11 is 27. And 27 minus 7 is 20. And then 20 plus 11 is 31. Okay, I have one last one to show you, and now this one's going to be a doozy, you guys. It's a doozy. Here it is. First term is 1, then we go to 6, then we go to 2, then we go to 12, then we don't know. Then we have a 24, an 8, and I don't know, and a 16. Now I'm looking for some sort of pattern here. Now here, let's see, I would add 5, subtract 4. Am I adding 5? Nope. Well, that one was debunked. It's not add 5, subtract 4. So let's try. The only way to get bigger, but if you're not adding, is going to be multiplying. So to go from 1 to 6, I would multiply by 6. Oh my gosh. 6. And then to go from 6 to 2, I could try subtracting 4 again. Then I would try multiplying by 6. Oh yeah. And then subtracting 4. So then I would be down to 8. And then I would multiply by 6. Oh, you guys, it worked the first time, but not the second time, because 8 times 6 is 48, not 24. Well, it's not multiply by 6, subtract 4, so we gotta go back to the starting board, try something else. Do you kind of see how you're not always going to see it right away? You kind of got to try some different things and see if they work. If they don't work, try something else. Okay, well, I know I'm going to multiply by 6 because it's not adding. Then the other way to go from a bigger number to a smaller number would be dividing. Now 6 divided by 3 is 2. 2 times 6 is 12. 12 divided by 3 would be 4. 4 times 6 is 24. 24 divided by 3 would be 8. Oh, you guys, we found it. 8 times 6 is 48. 48 divided by 3 is 16. We found it, you guys. So our pattern is multiply by 6, divide by 3. And that means our terms we're missing are 4 and 48. So, see how sometimes I'm not going to get it right away. I've got to try some different things. I know that if a number goes from a small number to a big number, I'm either going to be adding or multiplying. If a number goes from a big number to a smaller number, I'm either going to be subtracting or dividing. I mean, we have the tools in our toolbox. Sometimes we just have to try a different tool and see if it's going to work for this situation. So anyways, that is all that I have for you today. This is such a fun lesson. I always feel like a detective when I'm trying to figure out what the missing numbers are. So I hope you enjoyed as much as I do, and we will see you tomorrow.